start a new topic, linear inequation in one variable. It is an algebraic topic based on algebra. First of all, we must understand what is the meaning of the linear inequation. So the definition says that linear inequation is a statement of inequality between two expressions involving a single variable x with highest power 1. There will be two expressions. These two expressions will be actually connected by means of an inequality sign. Basically, we will take 4 different types of inequality sign here to solve the problems of linear inequation in one variable. So let us first of all check those 4 symbols, and we must keep these symbols in our mind, and their meaning should be properly kept in the mind. It should be well understood that this symbol is actually used for less than, this is the symbol for less than, equal to, this is the symbol for greater than, and this is the symbol for greater than, equal to. These 4 symbols we will use for solving the linear equation problem. So let us take one example here. The example first one you see, here 2 expressions are there as per the definition. 5x minus 7 is one of the expressions which is kept on the left side of the less than inequality sign, and the other one expression is 6 plus 2x. So these 2 expressions are connected by means of inequality sign. Here also you see 3x by 2 is less than equal to 6 plus x. So this is the linear inequation in one variable. Here the variable is your x. We have to find out while solving. If you solve this equation, you will get the value of x. That will satisfy the condition. That will discuss later on. This is also the linear equation. You see here also there is one variable x, and the highest power you will find that as per the definition, the highest power of the variable is always 1. It is always 1. In all these examples, you see the highest power of x is 1. So this is 4x by 7 plus 8 is greater than 5 minus 2x. Here also 2 expressions are there. They are connected by means of inequality sign greater than. The fourth one you see 6x minus 3 by 4 is greater than equal to 5 plus x. So all these are this type of equations you will find that when you will be solving the problems of linear inequation. That there will be a one variable, single variable, and the single variable power will be always taken as 1. The highest power will be taken as 1, and those equations will be connected by means of this inequality sign. Now, let us try to understand the term solution set of the inequation. Because when we will solve the equation, we will get its solution. So, what is this solution set of the inequation? It says that the set of values that satisfies the given inequality is called the solution set of the inequation. When we will solve the equation, then we'll find out the value of the variable. For example, suppose this is, we get a condition x is less than equal to 3, and here x belongs to natural number. So what will be the solution set for the x? It must satisfy this condition, x belongs to natural number. So the solution set for x is given as x is equal to 1 and 2, because 1 and 2 are the natural numbers which are found to be less than equal to 3. 1, 2 and 3, sorry. 1, 2 and 3. We include 3 because the condition is saying x must be either less than 3 or equal to 3. So we will include 1, 2 and 3. Now take one more example. Suppose the condition is x is greater than 2, and here the x belongs to whole number. W stands for whole number. So here, to satisfy this condition, the value of x should be a whole number, and it must be always greater than 2, because here the symbol is greater than. The inequality sign is given here as greater than. So what are the values which satisfy this condition? What are the whole numbers which will be greater than 2? So that is nothing but your 3, 4, 5, 6 and so on. Take another example. X is greater than equal to 2. Now see, here it was greater than 2 and here it is greater than equal to 2. And here also x belongs to whole number. So here you will find that we will include 2 also, because x is greater than equal to 2. So while writing the solution for x, we will take it 2, 3, 4, 5 and so on. So in this way, first of all, whenever the question will be given and whenever you will find out the variable x value, it must satisfy the condition also. So always the condition will be given in the question. When you solve the problems, you will find that the condition will be there and those conditions should be satisfied. That is what we call as the solution set of the inequation. Now, let us try to understand the replacement set. What is replacement set? The set of elements from which the replacement for the variable is taken is called the replacement set. It means one set will be given to you and the equation will be known to you. After solving the equation, you have to find out the solution from the given set. That given set is actually called as the replacement set. For example, if the replacement set is say for 0, 1, 2, 5, 7, 8, you have to find the solution set of the equation 1 plus x greater than 5. So we will solve this equation first. So 1 plus x is greater than 5. This implies that x is greater than 5 minus 1. Because whenever you will take the term from, you will transfer the term from left to right, then the sign of that particular term will change. Here it was plus 1, so on this side when it will go, on the right side of this infinity sign, it will become minus. So it becomes x is greater than 5 minus 1. On simplifying, we get x is greater than 4. Now, this is the replacement set 0, 1, 2, 5, 7 and 8. By solving the question, we got it as x is greater than 4. So we have to see from the replacement set that which are the values or what are the values which are greater than 4. Because here the condition says that the value of x should be greater than 4. So we have to choose all those values from the replacement set which are greater than 4 and that will be the solution set for this given equation. So when we go through this solution set, we find that 5, 7 and 8, these three values are greater than 4. So these three values 5, 7 and 8 will actually become the solution set for this given equation. Because these are the values which satisfies this condition, x is greater than 4. So all the values of x should be greater than 4 and from the replacement set we have got only 5, 7 and 8. 0, 1 and 2 will not be taken because they are less than 4. They are not satisfying this condition, x is greater than 4. So now let us take one more example based on that replacement set. In this example, the question says that if the replacement set is the set of integers between minus 6 and 8, find the solution set of, two bits are there. In the first bit, 6x minus 1 is greater than equal to 9 plus x. And the second bit is 15 minus 3x greater than x minus 3. Now, here the replacement set is the integer and it is in between minus 6 and 8. I or z is actually symbol for integers. So when you find out the solution, first of all we will write the elements of the replacement set as per the condition given in the question. Since integer condition is that minus 6, the integer should be in between minus 6 and 8. So my replacement set will be minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6 and 7. These are the elements which are in between minus 6 and 8. Now, let us try to solve these two equations and then we will find out the solution. So the first equation is 6x minus 1 greater than equal to 9 plus x. So while solving, we will bring all the x to one side. As I told you in the previous example, that when we transfer the terms from one side to another side, their sign actually changes. The sign of the term changes. Inequality sign will remain the same. So I am bringing this x to the left side and I am taking this minus 1 to the right side. So when I take this x to the left side, its sign will change. It will become minus x because here it was plus x. And this minus 1, when it will be taken to the right side, it will become plus 1. So it becomes 6x minus x will become 5x and 9 plus 1 will become 10. So 5x is greater than equal to 10. So finally x is greater than equal to 10 by 5 and x is equal to, if you simplify this, you find that x is greater than equal to 2. Now as per the condition, the x is greater than equal to 2. So we have to find out the solution for this from the replacement set, that which are the values which is satisfying this condition. Means which are the values in the replacement set which are either equal to 2 or greater than 2. So when we see here the replacement set, we find that the condition is greater than or equal to. So we will include 2 and then all the other elements which are greater than this 2, that is 3, 4, 5, 6 and 7. So the solution set for this equation becomes 2, 3, 4, 5, 6 and 7. Because these solutions, these elements from the replacement set actually satisfies this condition. Take the second example. 15 minus 3x is greater than x minus 3. So here again we will simplify this equation, solve this equation. The same thing, we will bring all the x to one side and take the digits to the other side. So as per the rule what we discussed previously and just now also in the first bit, that here it is x, when it will be taken to the left side, its sign will change, it will become minus x, and this 15 when it will go to the right side, it will become minus 15, because whenever we transfer the terms from one side to another side, the sign changes. This you have to always keep it in mind. Whenever you are going to transfer the term from one side to other side, remember the sign will change. So here the sign has been changed, and then we solve the equation. We get minus 3x minus x is minus 4x, and minus 3 minus 15 will become minus 18. So minus 4x is greater than minus 18. Now here again important point is that whenever you multiply the negative sign to both the sides, remember the inequality sign will get reversed. Here it is greater than, I have multiplied minus to both the sides, so it becomes 4x. So this inequality sign will now get reversed. It was previously greater than, now it will become less than. So 4x is less than 18, and so x is less than 18 by 4, and finally x is less than, if you simplify this, you will get 4.5. Now this here the condition is that the value of x should be chosen from this replacement set, which must satisfy this condition, x is less than 4.5. So what are the values which are less than 4.5 in this replacement set? So we find that minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. These are the values which are less than 4.5. So that will become the solution for this condition, x is less than 4.5. So our solution set will be minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. So now remember, to work out the questions based on linear inequation, there are some working rules which we have to adopt, and we have to keep those working rules in our mind so that without doing any mistake, we can come to the correct solution for the variable x. So let us discuss the rules one by one. Number one, as I told you, on transferring the term from one side of an inequation to its other side, the sign of the term changes, but inequality sign remains same. Already in the last two examples, I have shown you that whenever we are transferring any of the term from the expression from one side to the other side, the inequality sign will always remain same, it will not change. These are some examples. You see 2s plus 3 is greater than 7. This is an expression. And now I am going to transfer this 3 to the other side. So when I take this 3 to the other side of the inequality, the sign will change. But remember, the inequality sign remains same. Here also it was greater than, here also it is greater than. But see, the term sign has changed. Plus 3 has now become to minus 3. In the same way, 5x minus 4 is less than equal to 15. So if I transfer this minus 4 to the other side of the inequality sign, its sign will change. You see, 5x is less than equal to this minus 4, when it has been taken to this other side, it becomes plus 2. But the inequality sign remains same. Take the third example, 27 is greater than equal to 4x minus 12. This implies that now I am going to bring this minus 4, this 4x to left side. So when I bring this 4x, here it was positive. When I bring it to the left side, it will become minus 4x. So minus 4x plus 27 is greater than or equal to minus 2. So only the term sign has changed, but the inequality sign remain same. Take another example. 2x plus 5 is less than or equal to minus x minus 12. Now here I am going to transfer this minus x to left side and plus 5 to right side. So as per the rule, both when I take this minus x to left side, it will become plus x. At the same time, I am going to take this plus 5 to right side, so it will become minus 5. But see, the inequality sign remains same. So keep it in mind that on transferring the term from one side of an inequation to its other side, the sign of term changes, but inequality sign remains same. Take another rule. If each term of an equation be multiplied or divided by the same positive number, this is very important, same positive number. When you are going to multiply the terms of the inequation to both the sides with the same positive number, the sign of inequality remains the same. Again, there will be no change in sign of inequality. For example, suppose x is less than or equal to 8. Now I am going to multiply 3. 3 is a positive number. That 3 is multiplied to both the sides. So it becomes 3x and this side 3 into 8. But see, the equality sign will remain same. Means 3x is less than or equal to 3 into 8. That is nothing but 24. Now, see this second example. X is greater than 7. Now both the sides I am going to multiply a positive number 4. So when I multiply positive number 4 to both the sides, it becomes 4x is greater than 4 into 7. Now see, inequality sign is again the same, it is not changing. Take third example, 2x is less than minus 8. So here 3, if I multiply 3 to both the sides of the term, then it becomes 3 into 2x is less than 3 into minus 8. Again inequality sign remains same. If I take, now suppose in the fourth example, if I divide both the terms of the inequation by a positive number, say for 3. 3 is a positive number. So on dividing, I get minus 2x by 3 is greater than or equal to 7 by 3. And so on. So from all these 4 examples, it is clear that whenever we multiply the terms of an inequation or divide the terms of an inequation by the same positive number, remember the inequality sign always remains same. The inequality sign will not change. Now, the third point is, if each term of an inequation be multiplied or divided by the same negative number, the sign of inequality get reversed. In the previous rule, I told you that if they are multiplied or divided by the same positive number, the sign remains same. But remember, if you multiply or divide by the same negative number, the sign of inequality will get reversed. For example, if x is less than or equal to 6, and now I am going to multiply minus 4 to both the sides, because minus 4 it is a negative number, so the sign of inequality will also get reversed. So minus 4x will now be greater than or equal to minus 4 into 6. Similarly, if x is greater than 7, now suppose I am going to multiply with both the sides with the same negative number minus 3. So on multiplying, you will find that the inequality sign get reversed. So minus 3x is less than minus 3 into 7. Now suppose in the third example, x is greater than or equal to y. Now I am going to divide both the sides with the same negative number minus 2. So as per the rule, when you divide both the sides with the same negative number, then the sign of inequality will change. So x divided by minus 2 will be less than or equal to y by minus 2, and so on. Now the fourth one, this is also important, you have to keep it in mind, that if sign of each term of both the sides of an inequation is changed, the sign of inequality gets reversed. Now if you change the sign of both the sides of the inequality, the rule says that the inequality sign will get reversed. Suppose in example 1, minus x is greater than 6. I am going to multiply minus to both the sides. So when I multiply minus to both the sides, minus x becomes plus x and 6 becomes minus 6. Since both the sides sign is changed, so the inequality sign gets reversed. Here it was greater than, next step it will become less than. Take one more example. Minus 2x is less than minus 1. Now again I am going to multiply minus to both the sides, means I am going to change the sign of both the sides. So as per the rule, the inequality sign will also change. So 2x will be greater than 5. Minus 3x is less than 8. So now again I am going to change the sign of both the sides. So 3x will be now greater than minus 8. So remember that whenever we change the sign of both the sides in an equation, then the inequality sign will get reversed. The fifth one, if both the sides of an inequation are positive or both are negative, then on taking their reciprocals, the sign of inequality gets reversed. Remember, whenever you take the reciprocal of both the sides, the sign of inequality will get reversed. For example, x is greater than y. So I am going to take the reciprocal of both the sides. So when I take the reciprocal of x and y, I will write 1 by x is less than 1 by y. Means by taking the reciprocal, the inequality sign will get reversed. Take one more example. Minus x is less than equal to minus y. So now again I am going to take the reciprocal of both the sides. So minus 1 by x will be greater than minus 1 by y. And if you multiply this minus to both the sides, once again the sign of inequality will get reversed as per the rule number 4. The sixth rule is that if whole of the expression of left side is taken to right side and right side's expression is taken to left side, then the inequality sign gets reversed. It means when we take or when we interchange whole of the expressions from left to right and from right to left, then in that situation also the inequality sign actually changes. For example, suppose x is greater than 6. Now I am taking this x to right side and going to take 6 to left side. So as per the rule, this 6 will be now less than x because I have taken whole of the x to whole of that left side expression to right side and the right side expression I have taken to left side. So the inequality sign will change. Take another example. 2x minus 3 is less than equal to x plus 2. Now if I take this whole of this expression to right side and this whole of the expression to left side, then the inequality sign will change. It means 2x minus 3 is less than equal to x plus 2. This implies that x plus 2 will be greater than or equal to 2x minus 3 and so on.